Configure and verify NAT and PAT. So this chapter talks about network address translation. You probably have heard of this service before. You know that the IPv4 public IP addresses are running out. There is a shortage of IP addresses. So everybody at their local networks should be using private IP addresses. And in order to let those private IP addresses reach the internet, you will need to use address translation. So you already know that. So let's go to the terminology. Most of the times, or 99% of the times, you will be using the inside local addresses and inside global addresses. This is the most common IP addresses that you will be working with. The inside local and inside global addresses terms are used when you are talking about egress traffic that is going out of your network. So in this case, for this traffic that is going out of your network, the inside local is the actual IP address that your devices have, whereas the inside global is the IP address that represents your devices on the external networks. So the other 1% of the time you will be working with outside local and outside global. These are seldom used. The outside global is the actual IP address that an external host had on the outside network. And the outside local is the address that represents that host in your inside network. To configure NAT, you will have to define your inside interfaces and one outside interface with the commands IPNAT inside and IPNAT outside. And most of the time, 99% of the time when you're working with NAT, you will be using the command IPNAT inside source, IPNAT inside source, IPNAT inside source, IPNAT inside source. Remember that. In order to validate NAT, remember to use the command show IPNAT translations. So let's talk about types of NAT. There are several types of NAT. The first type is static NAT. With a static NAT, you will be translating IP addresses on a one-to-one way. So if you were translating private IP addresses to public IP addresses, a static NAT is actually a waste of resources, because if you had 100 private addresses and you wanted to use a static NAT to have them reach the internet, you will need 100 public IP addresses, which is a waste of resources. There are some usages for this. For instance, if you might have a server that has a lot of services and you don't want to do a lot of port forwarding configuration on your devices, you might as well decide to give a single server a whole IP address, for instance. I don't know. And there is a variation of this where you can use outside static NAT. This is the case I was talking to you about, where you will be working with outside global and outside local interfaces, IP addresses. So this can happen, for instance, if a company acquires another company and this new company happens to use the same IP addressing scheme. In that case, you will have duplicate IP addresses. And if you want to communicate both networks, you will have to work with the outside global and outside local IPs. So when with dynamic NAT, you have an improvement over static NAT when you can have a pool of inside global addresses, and the device will choose these IP addresses from this pool, and it will assign this IP address to a single inside local IP address dynamically. So this assignment will stop when the flow from the local inside local address stops, or when 24 hours have elapsed. Notice that this can be a source of incidents when you're working with this kind of devices, because you might come across a case when someone reports that transmission of traffic works, but only for 24 hours straight. So if that happens to you, you might start thinking that there might be a NATing device in between. So remember that these NAT timeouts can be a source of problems. In order to configure dynamic NAT, first you have to define a pool of available inside global addresses. Next, you will have to define what inside local addresses can use NAT service with an ACL. Finally, use the super command IPNAT inside source in order to pull everything together. Now, this port address translation is the kind of NAT that is most used around the world. You are probably using it right now. All the devices that the ISPs provide to customers at their homes will use a port address translation. With a port address translation, you can translate many inside local IP addresses to only one inside global IP address. This is achieved using a mapping of TCP ports to local to inside local IP addresses. So in theory, knowing that there are about 65,000 TCP ports per IP address, in theory you could say that one IP address could provide NATing to 65,000 inside local IP addresses. So this is only in theory, because in reality these devices will assign a set of TCP ports to each inside local IP address. Think like each inside local IP address will consume about 20 to 40 TCP ports. So you can also use a pool of inside global addresses to do this. Most ISPs do this. Regularly, ISPs will buy a lot of public IP addresses, and they will put them inside a pool in order to do port address translation. So using a pool for PAT will provide internet access to thousands of private IP addresses. You might probably Google carrier grade NAT, and this is something that carriers do. In order to configure this, first of all, optionally define a pool of IP addresses. If you have many public IP addresses, this is optional. You will have to define what inside local addresses will use this service with an ACL. And finally, use your super command IPNAT inside source to pull everything together. And don't forget to use the overload parameter in order to use PAT. That's it.